say, wow.
Well, look at it. Look, 1 second.
And
like, the ring is facing this way, and when it comes out, it's facing this way.
So real.
That's interesting, isn't it? Yeah.
It's
So that
facing-
would follow. That would follow through with the
rocking,
angle.
yeah.
Yes. Yeah. When we put it in, it was shaking a bit.
But when you go down, it disappears.
Yeah,
When you go down.
When you go down for
Yeah,
it.
that's right.
It
So we have to.
disappears.
There's a certain angle at which you have to view it. Just move down, and when you can't see
Or it
it,
starts to
when you
disappear
can't see it, say
slowly.
it. How low? Hey, I can't. No,
I
I'm
can't.
losing half of it.
Wait,
I've got
I-
lost. I can't.
I've lost half.
I've
You lost
lost
half?
it. I've
No,
lost
move
it.
up a bit
I've
so you
lost
lose
it.
just
I'm
half of
starting-
it.
Okay, I lost
Okay.
About half?
Half.
Yeah, we're
This
all
is half.
okay. Now we're losing 3/4.
Oh my gosh. That's
Yeah,
neat.
yeah. And it's such a funny feeling because you expect to grab some hold of something like that, and it's not there.
You know, sometimes that camera can really trick you.
We're going to look at things that might sink or might float. Let's have a try. Try some things here. Come in and see if they sink or float. That's the way. Now, the ones that float, we want to put out in here. Let's see if we can just, right? Try some.
That floats.
Yeah. Oh, okay, you got a couple. The knife sank and the fork floated. Down
Why
they
is
go.
it that some of them sink and some of them float?
Well, it's related to the density of whatever it is. And that's like the quantity, quantity of matter there, or mass, as compared with how much space it occupies. So it has a lot of quantity to a smaller space, down it goes. Now, how come that one sank and this one floated?
Maybe it's because the way you put it in.
Oh, okay.
If you do
Oh,
that.
yes, all right.
But if you do it this way,
Ah,
the air stays in there and keeps it up.
so you've got more volume there, haven't you?
Yep.
Than if you did it the other way. There we are. Okay, let's have a look at the things that floated. Okay, just lift them out and pick a couple and lift them out. Now, suppose we took that shell and crumbled it all up and stuck it together. It would float?
No.
This is because it wouldn't, because this is spread out, isn't it? More volume. Decrease the volume with the same mass, and good chance it'll sink. Well, I have a couple of rocks in my pocket, and when I bring them out, put them on the water and see what happens to these rocks. Just try that.
They float.
Yeah. So why would that be now? What do you think?
It looks like they have little air pockets in there.
So what
there's
happens
less
to the mass
mass.
of it? That's right, yes. And that's what makes them float. And they actually come from, a volcano. And pumice is the name of the rock. Let's break that, into chunks of 4. So each of us has a chunk of plasticine. Right, and here we are.
Thank you.
Okay, now make it into a sphere first, into like a ball shape. And see what happens. Just squeeze it around. Yeah, to make like a ball. Okay, now there we are. Right?
Right.
Okay, now put it in. Let's put it in and see what happens here. Down it goes. Yeah, okay. Now what we want to do is flatten it out. So take it and see if we can flatten out this plasticine. Make sure that you get, the bottom of it all covered, all right? And then just make a little ridge around the edge. Now you can see how those great big ocean liners can actually, stay afloat in the water because of that volume that they take, They say that when you put something in water, you're displacing the water, and there's a force, an upward force that comes in the water for anything that is displaced. Remember how it sank before? So all we're doing is increasing the volume, right, of it. It's the same mass as before. Let's see which of these boats will hold the most, which of our barges here. Okay. Now, put one in each. Okay. Okay. Another one. Ready? Oh. Ready? And another. Oh, say. Oh, down it goes. Lift it off, please. Oh.
No.
There she sinks. Yeah, okay. Oh, now I'm going to lift it off, if I can here, and just put it over here, too. And there we are. So the more it's spread out,
The more it can hold.
yeah, the more water it displaces, area of water it displaces, and the more it pushes up. And that's how that works. This is how we make one type of submarine. Put the elastic on here. Now we just have to wind that elastic band around the balloon until it's there good and tight. Then we put the lid on, like that. There we are, and we've got our submarines. Now take your submarine over and undo the lid a bit and just let it fill with water. Then put the lid back on again. Let it fill up. Okay, that's the way submarines do. They have tanks on the side that take in water so that it will sink. Now, take the other end of the hose and blow gently. Ah. You know, that works the same way as a fish bladder. You know, well, when the fish wants to rise to the surface, they just fill up a little bladder inside.